Vectors is what we are going to be looking at today. Vectors is what we are going to be looking at today. So, I want us to, we are going to be moving at the speed of light. So, I want you to follow me accordingly. The last time we were taking vectors, we're looking at the sum of vectors. So, let's take this, find the sum of the following The first one, PQ plus QR plus RS plus ST. Second one, AC plus CL minus ML. The third one, GH plus HJ plus JK plus KL, and then plus LG. Life is good. The fourth one, we have AB plus BC plus CD, and then plus DB. Now, what this just involves is that you do a rearrangement. But this is what you need to be familiar with. You do A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U. Now, we can stop there at U, because if you look at the questions given to you to find the sum of the vectors you have available, none of them goes beyond the U. So we can stop there. So now, what's the essence of writing this alphabet in this way? It will help you to know the particular vector that is not arranged the way it is supposed to be arranged. It will help you to know the vector that is not properly arranged. So now let's take the first one. The first one is PQ. So you come here, you have PQ followed by Q arrow. They must follow the same order. So in peradventure, you come across any of the vectors that is not in order. For example, if this is kept here, if this is PQ plus Q arrow, if this is PQ plus ST, and this Q arrow is taken the other way, you have to rearrange it. So that's the essence of putting this now. So we take it again, PQ, this is PQ, Q arrow, so that means it's going in order, RS, then ST. So this one is very simple. What you just do, you take the first, since they are already in proper order, you take the first letter of the first vector by your left hand side, and you take the last letter of the vector at your right hand side, the last vector. So you're going to take this P and T. So your answer is just what? PT. This is your answer. Then let's go to the next one. Number 2, we are looking for the sum. What they said is find the sum of the following. That's, you're looking for the sum of each of the vectors given to you. But now there's a rule in vector. When you are adding a vector and you come across a negative sign, in one of amongst the vector precisely, if you come across a negative sign amongst the vector, you have to change it to a positive sign. So now what you are expected to do here is to change ML minus ML to positive. So what you are supposed to do, permit me to take out this part. We are going to bring it back again. So what you are going to do now is to rearrange. You rearrange to take away the negative. So you are going to have AC plus CL. How do you rearrange to become positive? It will become, so you take the L this way and the M the other way. As simple as that. Nothing else. Nothing else. So, but then you have to now go and look at the arrangement in alphabetical order to see if they are actually in order. So you have A, C. Good. This is good to go. Then you have C, C, L. That's good to go. Then you have L, M. So it goes in order. So you go ahead and take the first and the last. You take the first and the last. So your answer is actually what? A, M. A, M. So if you do not take note of this, you may just rush and go ahead and say, it's simple. You take the word A and the L, and that's going to give you a wrong answer. Did you get that? So now let's take the third one. Let's take the third one. I'm taking this out. I'm taking this out now. The third value was number 3. It says GH plus HJ plus JK plus KL plus LG. This mark on is showing you the direction of the vector. You know, we are told that vectors have magnitude and direction. So this is actually showing you the direction. Sometimes some text will write it, we put it this way. I don't know if you've come across something like that. Sometimes it's put this way. So it's showing you that this is the direction the vector is actually going. In fact, this is actually the right way it's supposed to be written, to show you the direction of the vector. To actually show you the direction of the vector. So let us go ahead. So we look at the arrangement with alphabetical order. So we look at it now. GH, let's go to GH. We have here GH. This is in order. So we take it, then HJ. HJ is in order. GH. HJ. This is in order. JK. So what goes? JK. This is in order. Order in the sense not that it must be close, but in alphabetical arrangement. In alphabetical arrangement. So the GH comes before HJ. Did you get that? So now JK goes next. JK goes next after HJ. JK goes after HJ. So this is good to go. Then what next do we have there? We have KL. KL. So KL actually comes after JK. Well, now we have LG. LG. Did you see that now? This LG. So does it actually come after? So that means you have to rearrange this particular one because it's now LG. So going back to where it was before. So you have to rearrange it. So GH plus HJ plus JK plus KL plus, this is actually now going to be what? GL. Because it is not in order. So this is now GL. Did you see that? It's not supposed to go LG. It's supposed to come GL. Are you following that now? So you are rearranged. But now there's still another work you need to do here. So now does KL come before GL? No. GL actually comes after GL. What goes next is what you are going to look at now. So let us look at it very carefully and see how we can rearrange it now. So after GH, what should come next is actually supposed to be what? GL, because this is the letter that comes first. So you have to rearrange it again. So we have GH plus GL plus HJ, I'm bringing down this one, plus JK plus KL. This is how you have the arrangement. So what you have there is this and this, which is also equal to what? GL as your final answer. But you may look at it from this end, you see that you're still having the same GL, but you have to arrange it how it's supposed to be. Did we all get that? All right.
I'm lost.
Who is lost?
Dayo, sir.
Okay, Dayo. All right, where are you lost? Where are you lost?
The second rearrangement, sir.
The second rearrangement. So now what I was saying is you always consider, please mute your mic, consider the alphabetical arrangement. Consider the alphabetical arrangement. The way we have A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U. Now, it is supposed to go in order. So if you are having A, B, what you should have next is B, C. For example, if you are having A, B, what maybe if it is not B, C that's coming next, it should be maybe something around this part, D, C. Sorry, D, E. So you cannot have A, B, then you have D, E, then later you now have C, B, C. It ought to go in order. So what we had here is when we checked this one, the vector given to us, GH, we have GH, GH. The next vector, that is, this one is good to go. HJ, we have HJ. Then we go to JK, that's JK, good to go. Is in order. From here to here is in order. So let's go to KL. KL is in order. Then we come here, LG. Yes, LG. Is actually supposed to be GL. Do you understand? Based on alphabetical arrangement. That's what I'm saying. Based on our alphabetical arrangement. So you have to now rearrange that particular one. So you take it GL. So because G comes before L, it is not L that comes before G. That is just as simple as that. So what you do, you just swap the position. You swap the position. So all this maintains. But now that you have swapped the position, you have to also look at the arrangement of the vector, how it should go. So GH, if there's a GH here, G, what comes again after G? What should follow GH is another G, GL. So you have to bring this one here, which is what we brought here, and arrange the other ones the other way. So you take the first and the last. You take the first letter of the first vector, then you take the last letter of the last vector, which gives you what? GL. Simple. Did you get that now, did I?
Yes, sir. Thank you, sir.
All right. So let's go. Let's go number 4. The fourth one is AB plus BC plus CD plus DB. So we follow the same principle. Let's look at it. We have AB, this is good to go. Then we have BC, this is good to go. CD, this is good to go. Then DB, DB. So what do we do now? What do? We have to rearrange. AB plus BC plus CD plus what? BD. That's how it is supposed to be. So you now take it back because it shouldn't be DB. It should be BD. Did you get that? So let's take it back. Let's look at it again. AB, BC, CD. So what B is here and there's a B here. So this one should actually move instead of stressing yourself. So this, there's a B here, there's a B here. So what comes here? C, after C is D. After C is D. So you bring the what? You bring the BD here. Then you move the what? The CD this way. So your final arrangement is the first year and the last year. So you have what? A, D. You can see from the first distinct arrangement that is actually still A, D. But sometimes it may not fall that way. But you know, for explanation purpose, it is very important that you rearrange it the way it is supposed to be. So this part is actually like a confirmation to what you did here. So you should get, you remember the previous one we did, we actually got this one to be the just the same way we got this. So it's a sort of confirmation. Did you get that? All right. So I will assume the quietness is that we got it rightly. So you know the beauty about this vector is that you must always consider the alphabetical order arrangement. That is what you need to consider, alphabetical order arrangement. Now, if you're not considering alphabetical order arrangement, it becomes an issue for you to get your final result. So if you just look at this, because this is where a lot of people make the mistake, this DB, so they will just be looking at D here, D is here now, so D follows, and so they don't consider this. They don't consider this part that it's not supposed to be DB. It's not supposed to be going back because the direction, that is why I said this is how it's supposed to be. This is how the actual thing is supposed to be. Do you understand? The direction of the vector is this way. It is not this way. Are you getting that now? So this is what you should understand about it. What's the direction of the vector? The direction of the vector is this way, not backwards. So that is that about that. I'm very glad that we got that, and it's very easy. So but let's push on to the next part. I like this one. This one is actually very interesting, and you need to give me your attention. I need your full attention. Without that, you may be a kind of confused. Now the question says, okay, A, B, C, D. A, B, C, D is a square, precisely a quadrilateral with T and U. T and U are the midpoints. T and U are the midpoints of SP. T and U are supposed to be the midpoints of SP and QR respectively. Show that PQ.
So please, your board is one side, it's not stable. The board is not.
I'm coming.
You can't see the other left part.
Okay, I'm coming. Is equal to 2TU. I observe we have some visitors in this class. Some people have not seen before. All right, but let us go ahead. We have ABCD is a square. Precisely, it is a quadrilateral. With T and U. T and U are the midpoints of SP and Q arrow respectively. There's a midpoint, there are two midpoints, SP and Q arrow. The question now says show that PQ plus ROS is equal to T2TU. So you need to do a kind of like you need to do a proof. You need to do some sort of explanation. That's what the question is actually saying. But the first thing is we need to ask ourselves, yes, even if it is a square, but in the bracket, parentheses, they said what they are saying that is a quadrilateral. So the question to us now is that what is a quadrilateral? A quadrilateral is actually a polygon with 4 sides and 4 vertices. 4 sides, that means it is actually a square. I don't know why they even put up this quadrilateral. So here and here is the same thing. So it is actually telling you, maybe this is actually to pass the message to you, that when you are representing this vector, it should have 4 sides.
Is this message recorded?
Yes, it's recorded. It's recorded. So the message here in this question is that the vector, the direction of the vector is actually moving to 4 sides. That's what it's telling you now. There's a way the movement is this way, so we need to represent it pictorially. You know, there is what we call graphical or pictorial representation of vectors. So you have to consider a diagram. You have to draw a diagram. So you say you are told that PQ. So what you are actually first to do is what? AB, and AB, C, D. This is the movement of the vector. This is the movement of the vector. But you are told that the vector has a midpoint. It has a midpoint. So apart from having midpoint, that it is a square. So you are actually supposed to join it this way. That's the first thing. After showing the direction of the vectors, then because you are told is a quadrilateral and it is a square, you have to make it a square. So we've made it a square. First thing. And then you go ahead and says T and U are the midpoints. Mid actually means middle. So there's a middle point. And this is so you come to the exact midpoint, middle, and you mark it. And he said that TU, you call it TU. That's the midpoint, TU. This is the midpoint of the quadrilateral, or the movement of the vector. So we go back to the question again. We look says at the midpoint of SP and Q arrow. That means we need to actually take out AB now. So SP. So there is the first midpoint of T is SP. That's the first midpoint. T, SP. And U is Q arrow. U there is what? Q arrow. So you have Q arrow. The midpoint U is the midpoint of Q arrow. That is why they say respectively. So now that you have presented it this way, you are told now to show that PQ plus ROS is equal to T2TU. So you need to do some work now. And make a proof. So how do you make this proof? The first thing you need to see in this diagram that you have presented now is that the diagram is divided into 2. The diagram is actually divided into 2 equal parts, if I should put it this way. So the first part of that diagram is a PQ, and the other part is what? ROS. PQ, RS. So now that we have it like that, is that this part like this is the first part, and this part is another part. So we have PQ, then we have UT. We have S arrow and we have UT. Those are two parts of the angle. So the first thing we are going to do now, we consider the lettering on this particular diagram, and then we have to replace each of them based on the chain of the vector. So this vector now has a kind of chain. So this chain that the vector is having now, PQ, the first chain, the first direction of the vector, then RS, another direction of the vector, we are going to separate them. So how do we separate that now? So let us first of all look at PQ. The first part of the vector there is PQ. So we have PQ is equal to PT plus TU plus UQ, which is the first. So this is what we are going to do now. Let's separate it. Let me take out the question so that I write it up for everybody to see. So let's separate the diagram now. PQ and TU. Then we come here. This is another TU, S arrow. So you see that it still remains as a quadrilateral. We have separated it because it has a midpoint. So now that we have separated it, we have to look at something now. The thing now is that we look at PQ. The PQ that you have there is actually equal to PT plus TU plus UQ. This vector, normally, okay, most people must have missed the first class. In the first class, I think we showed the movement of vector. So on this part now, we have PQ is equal to PT. This part is equal to this part, PT, plus the other part, TU. This first part, where the initial direction of the vector is PQ, will stand alone. It will be equal to the sum of PT, the sum of TU, and the sum of UQ. That's like a rule. So just like we are going to have in the other parts, the other part now, what's the other part? S arrow, the beneath part of the vector. Remember, we have taken care of this part. So let's look at this other part of the vector. S arrow. So from what we arranged here now, as the same rule we are going to follow to take care of the arrangement. So now we have S arrow. What next are we going to have? Anybody? What next are we going to have? Yes?
S arrow equals to arrow U plus UT plus CS.
No, I want you to follow this arrangement now. PQ is equal to PT. PQ is equal to PT. Yes. So if S arrow, what do we go next now?
ST.
Awesome. ST plus. So what goes next?
TU.
TU. Yes, this other part now. TU. And then plus what?
UR.
Awesome. UR. So that is what we have in first place. And remember that the question told you that PQ plus RS is equal to 2TU. PQ plus arrow s is equal to 2tu. So let's take this one out. Let's take this out. So you are told that pq plus s arrow is equal to 2tu. So you want to prove a point. So this is p. They say p is equal to this. So let's take it now. PQ rather is equal to this. So let's bring PQ now. That means it's going to be PT plus what? TU plus UQ plus, remember it is PQ plus S arrow. So what is S arrow? This part of the vector. So we bring it down, ST plus TU plus U arrow. Are we all following? Are you following me?
Yes, sir.
All right. So it's just simple logic. You want to prove that this is equal to this. So if P and Q, if PQ is this, so substitute the value, bring PQ, which, PQ, yes, PQ, bring PQ into this place. So you take out PQ and whatever the value of PQ is, put it there. Then you come to S arrow, which is plus S arrow. What is the value of S arrow? Whatever the value of S arrow is, bring it here, which is also equal to this. You want to prove that the whole of this is equal to what? 2tu. That's what you are trying to prove. Did we get that? So now let us look at it very well now. There is something that is happening there. There are some things that look alike from the arrangement of the vector now. Follow the principles of rearranging the vectors. Some things look alike, so we need to put them in order. So let us start now. First, we have what do we have there now? In this arrangement. What do we have in that arrangement? Can anybody look at it very well and tell me what we have there? It is actually PT. We have PT plus TU. There's a TU here. There's a TU here. Have you seen that? So you bring it close. TU plus Q arrow. Sorry, this is UQ rather. UQ plus what? ST plus U arrow. Plus U arrow. So, but that this UQ and U arrow, you still need to do another arrangement here in line with what we had said before concerning alphabetical arrangement. Please don't forget that. So this one will lead to one. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U. I think it stops at U. Exactly. U. It stops at U. So let us look at the arrangement now. So what should come first? What should come first? PT. PT, Abi? PT. Yes, PT comes first. Then TU goes. Is that what goes? Yes, TU. TU, TU. TU, TU. So we'll bring the TU together. Then it goes UQ. UQ. Remember, we have to put it the other way. UQ. Then we have ST. ST follows. Then the last one is U arrow. U arrow. So let us rearrange them. So we take PT down again. Plus, this is actually what? 2TU. TU plus TU is what? 2TU. Am I correct?
Yes, sir.
Okay. All right. So let us go on. What is the next thing we need to arrange there?
We arrange the U, Q to be Q,
Okay.
U.
Okay, let's just put it first. Let's just bring down the ST. Let's bring down the ST. This ST, then we bring a UQ plus a U arrow. Let's do that first. Let us do that first. So there are things before you even do that arrangement. There is something else happening here. There's something else happening there. I want you all to look at it very well and see something is happening there. There's a T in this P, PT. There's a T in this ST. There's a U in this UQ. There's a U in this UR. So you can also do some kind of rearrangement. So we bring this one here, 2TU. Okay, let me take it up. Let me take it up. Let me take this part off now. So we have 2TU plus PT plus ST. We're trying to group them the way they are. Then UQ. Please mute your mic. Whose mic is on? Mute your mic, please. Plus UR. Have you seen that rearrangement? So what we actually have is 2TU plus PT plus ST. We are grouping this plus UQ plus UR. But that doesn't stop there. What you are told to prove, that PQ plus SR is equal to 2TU. That's what you are told to prove. So, but we have reached this point now. We have reached this point. So let me take out this part. Now that we have reached this point, there's something else that we need to do. So at this point, we are going to go back. We are going to go back to the diagram. We'll go back to the diagram. So let me bring up the diagram again so that we can follow accordingly. This is the diagram that we have there. From the diagram, now that we have reached this point, there is something we need to look at in respect to the diagram. So you are seeing that you have PT. You have PT. You have PT here. PT, and you have TS. PT, TS, which were the parts that we divided based on the midpoint. You remember we divided this diagram into two halves. So because there were two halves, what it means is that this part of the diagram, the first part, the first diagonal, PT, is actually equal to, PT is supposed to be equal to TS. PT is supposed to be equal to TS. But since the diagram were separated, it is now going to mean that PT is equal to minus ST, because it's going this way now, ST. So it's going to be minus ST, which you can also rearrange. Remember the thing we did in the first part, you can also rearrange to make it PT is equal to TS. So same way, QU. Same way, QU is equal to what? What is QU equal to from what we have in this other part? Anyone? QU is supposed to be equal to ROU. But since the diagrams were separated, that is the quadrilateral was separated, it's going to be equal to what? Minus UR. That's another thing we need to know there. So you are going to now bring what you have here. You've been able to come up with something else from the diagram. There is where we stopped. Where is that wipes? I'm taking out the whole of this. This is where we stopped, okay? taking this out. I'm still leaving this because that's what we are proving. So now that we have 2t plus pt plus st grouped plus uq plus ur, what we are going to do now is you substitute the values you have for pt and qu into the what equation. Are you getting that? QU. It's almost like what I wanted us to do, but I want to show you the pattern, two different patterns. Like, you know, when we arrange the alphabetical order, what were we supposed to do? We're supposed to rearrange this, am I correct? To Q arrow. To Q arrow. So now we are going to substitute these values into the equation. We're going to substitute the value into the equation. So here is actually supposed to be in respect to A, B, C, D, E, F, G, H. This part has supposed to be another arrangement. So, but let's go. 2TU plus PT is equal to minus ST. PT is equal to minus ST. So wherever we see PT, what do we put? We're going to insert there minus ST. So you have minus ST plus ST. Then you bring the plus. Then QU, which is actually the same thing as UQ. UQ is what? UR minus U arrow. So you have minus U arrow plus U arrow. Are you seeing that? So what happens there is that this goes away and this goes away. So what are you going to have left? 2TU. So you have successfully proved that PQ plus S arrow is equal to what? 2TU. Did we get that? Looks funny. Hello, are we there?
Yes, sir. Yes, sir.
Okay, did we all get it?
At the point now, I was lost.
Where were you lost?
I don't just know, safe.
Now why are they bringing all these things?
No, but when you added these two this thing back, I think from that place I didn't really get that.
Okay, from here?
From this. So,
Okay.
yes,
from
that
here.
place. No, from the down. This PT equals to minus XT.
Okay, all right. So now remember, because we don't have the space, that's why I kept managing the space. So we had to bring back the diagram after we got to this part. After we got to this part, because we are trying to prove something. When we got to this part, you are now like at an end point. The end point is that you have here and you have here, and it cannot go. How do you prove from here? How do you prove from here that PQ plus S arrow is equal to 2TU? That is the question. How do you prove from there? You cannot prove from that point. So what you need to do now, you have to go back to the diagram. What is PT in the diagram? PT is actually equal to the other part, because this is a quadrilateral. This part is equal to this part. This part is equal to this part. And they told you to have that it has a midpoint. So that midpoint means that this point and this point should be equal. So it is just equal. Now this equal. That is, they are the same. This side is the same thing with this side. So for example, if this point here to here is 2, what is here to here is also what? 2. That's why they specified quadrilateral. So if here to here is 2, here to here is also 2. That is just the extent of this PT is equal to what? ST. Any way round. I don't know if you get my point now. So the PT is actually equal to what? TS. So if in vector form, if you are saying PT and you don't want to say is equal to TS. You are saying is equal to what? ST, because you are just trying to prove a point now. So that in proving that point now, you just say PT is equal to minus ST, because you are taking the vector the other way around, the opposite of that vector. If you go to unit 1, you will see that aspect. So the first part of the vector is equal to the opposite side of the vector, so which is a negative, represented in a negative form. The same way with this other part. So you substitute what you have there into this part. That's what we're trying to do, so that we can take off a particular part out of it. So now that we have gotten to this point. Okay, John, I'm coming to you. Now that we have gotten to this point, we substitute the value of PT and QU or UQ, anyone, whether UQ or PQ, into this part that we have. When we substituted it, PT, we said PT is equal to minus ST. So this is PT, and ST is on its own. So you take the 2TU plus PT. What is PT? We got PT as minus ST. So you replace it to be what? Minus ST. Then you bring down the plus, you bring down the ST, you bring down this plus again. So we have QU is equal to what? Arrow U minus arrow U. So you bring down you substitute the value of UQ or QU. You substitute the value thereof, which is equal to minus U arrow, into this part. You take this out, you put the value you got, you bring down the plus, you bring down the U arrow. So now that you have it like this, you could even arrange it like this. You know, my pattern is always strike out the negative and the positive. It's like doing 2U plus and minus is what? Minus ST. Plus times plus is what? Plus ST. Plus times minus is what? Minus U arrow. Plus times plus is plus U arrow. So what is 2TU? So you bring down 2TU. Minus ST plus ST. Minus 1 plus 1 is what? Is 0. So this is 0. Minus U arrow plus U arrow. Minus 1 plus 1. Minus 2 plus 2 is 0. So this goes away. You get what? 0. So 2TU minus 0 is equal to what? 2TU. Remember from the onset, what we had there was PQ. What we had is PQ plus S arrow is equal to 2TU. They say prove that this is actually equal to this. All right, John, let's hear from John. Yes, I'm with you, John. Okay, the other John Iyere. John number 2. Yes, John, go ahead.
Okay, I'm the one that to say something. Okay, about this, I'm bringing up this diagram again. Okay, you know, you did something like PT equals to minus ST. Then you came here and then QU equals to minus UR. Okay, so what if, like, okay, for this PT, you use PT equals to minus ST, which is you are starting from the S down to the T.
Yes.
Then here you are starting from the U down. Like, what if, does it mean that we can't do PT equals to DS? Or this one, QU equals to RU? Like, does it really matter that we need to arrange it somehow? Because the arrangement is somehow.
Okay, all right. So let me show you. The vector is actually moving PQ and also moving S arrow from the question itself. This is the question. The vector is moving PQ this way and S arrow this way. But they told you that from the question itself that it has a midpoint. Is that same with everybody? Is there any other person that has not seen the board? John, you are not seeing it at all? Because you are the one that asked the question, so I need to explain so you understand. John, are you there? I guess it's network from your end.
We can see the board, sir.
Okay, all right. So maybe you will refer to the recording because the recording this time is very sharp. I mean, it's straight to YouTube, so you can get it clean. So the movement of the vector is PQ, PQ. The other part of the vector is S arrow. That's the first movement. And they told you that it has a midpoint. That midpoint means that it says the midpoint is T to U, T to U, T to U. And from the question itself, they said that you have another movement from PT. You remember from the question is what? PT, PT, which is what you have here. There's a movement here, PT. And then there is another movement again from the other end, which is what? What's the other movement? Can anybody look at it and recognize?
QU.
QU. Yes, that's the other movement. So QU is another movement now. So, but the vectors, this is how vector moves. When it moves like that, this one moves this way, this one moves this direction, this one moves this direction. So now, this other one now, PT, is moving this direction because they have been separated. These quadrilaterals have been separated. So if this one is going this way, this other one will be going this way. So now that we have separated now, so this one is coming like this, this is going like this is going like this should be going like this. So this is how the movement of the vector is. This other one, they are original. This is the original movement from the beginning. PQ, PQ, S arrow. So the remaining movement now goes this way, ST, TU, UQ, UQ. Which is this UQ. Do you see now the movement UQ? UQ. That's the movement. Then U arrow. So let us go to the other movement now. U arrow. So where does it face now? Based on what you arranged in your questions, U arrow. This is how it moves. Where's the last part now? The last part is what? Can somebody look at it? What's the last part? From here. ST now, we've gotten PT, this movement, ST is ST, so this is how it moves. Remember that I said, even if I didn't put all the line, this is how vector is supposed to be written. So that is how you arrange it on the diagram. So the movement there is PT, this is how it moves. So it's showing you the movement. You cannot put it this way. You can't put it this way. You have to put it the way the vector is moving. It's always moving this way. So ST, where's ST? ST, so this is the movement, plus UQ, this is the movement, plus U arrow, this is the movement, PQ, this is the movement, S arrow, this is the movement. Did we all get that? So it's just about the movement of the vector. So forget the fact that I've been writing P, T, S, T. Always have this on top. Though in the course material, they will always write like this. But this is the standard way of writing vectors. That's the standard way. How many of us have seen it maybe in a textbook or something? Have you seen it like this? Even in most, in the exam questions, some exam questions, TMA, you will see it like this. Have we seen it like this in our exams? Anybody can you confirm that? Are we there?
Yes, I've seen it.
Okay, yes. So that is to tell you that is how it's supposed to be represented. So probably those who were doing the course material maybe could not get how to draw that sign. So when you see, if you are told now, John and the rest of us, if you are told to represent AB plus, let me bring up one, AB, which one is that, plus BC plus CD plus DB. If we are to represent this in a diagram, since it's already in order A, B, C, C, D, D, B. Remember we rearrange this one now. So when we arrange, what did we get? We had AB plus BC plus what did we get there? Was the arrangement in order? Is the arrangement in order? Are we together? I want somebody to answer. Is this arrangement in order? What's supposed to go next?
Is DB.
Yes. BD.
DB should go next.
Yes, BD. So you take it back now. Yes. So it goes next. What? BD plus what? CD. Is that correct? So now, yes. Now that we have it like this, and you are told to show. So John, this will help you to understand it. Show the movement of this vector, which is like this. So we have AB. What next do we have? BC. So let's put it C. Then we have BD. BD. BD is somewhere this way. BD. So D is here. So we have a CD. CD. So let's show the directions of the movement now. So AB, BC, DB, BD, and CD, CD. CD. So there are some vectors you have. You see now you've gotten a triangle. Have you seen anything like this? Maybe I think you will even come across it in your course material where you have yes a triangle like this. So it's about what vectors is about. They are just telling you the direction. So sometimes when you now see this kind of arrangement, you now have a right angle triangle which is 90 degrees. So now that you have here now, if they give you the value, they say BC is equal to 5. DB, which is DB, or okay, sorry, BD is equal to 3. And what's the last one? CD is equal to okay, X. For example, they say find CD. Sometimes they can, okay, when they've drawn the vectors like this, they say find CD. So what are we supposed to do here? Anybody, I need somebody that's very sharp to give me the answer. What are we supposed to do to get CD? What should we do to get CD? A very sharp one.
Is it angle in a right angle triangle?
Yes. Somebody that will get it now, I'll just stop small recharge for you. How do we get CD? Okay, so let me save the time. The way to get CD is to do what? Apply Pythagoras theorem. And we did that in the first class. Which we have A, B, C. When you obtain a right angle triangle, what do? You have A plus B is equal to C. Do you remember this? This is Pythagoras theorem now. So thereby, or you say A square is equal to B square plus C square. So A is actually equal to what? The square root of B square plus C square. So what you are going to do, you can name here A, B, C. So A now, let's call here A. The missing part is equal to what? The square root of whatever it is. Say 5 square plus 3 square.
3 square.
Yes, which is equal to what? 25 plus 9.
5 plus 9.
Yes, so whatever the value is, 25 plus 9 is what? 34. So the square root of 34 is actually the other part. That's it. That's it about vector. Did you see that? So that's how it works. So first thing you need to know is, thank God that I had to just tell you about this. Where is the vector going? This is the movement of the vector will help you to know how to arrange the diagram. So it is the movement of the vector, the way you are seeing it. They say BC. That is why I had to take out time for us to go back to primary school to write A, B, C, D, E, F to Z. So you can always arrange it. If you don't rearrange, you will not get the way the vector is flowing. So let us assume we did not rearrange the vector. Let's see if we will get it right. Let us assume we did not arrange the vector now. So this is it. Let's see something. AB, BC, BC, CD, CD, DB, DB. So let's get the movement now. BC, CD, DB, DB. So you see the way the vector is moving now. Like I told you, when you do your rearrangement, remember when we rearrange, we still got AD at the end. So it should always go in a way. There's a difference between what we have here and what we had in the other one. The previous one, how was the angle moving? How was it moving? Can anybody look at it? Remember, if you drew it now, because I just drew that from my head. Is there a difference with the movement?
Yeah.
There's a difference, Abi?
Yes.
All right. So that is the way it is. So you must know that is the essence of rearranging it so you can get it the way it's supposed to be. All right. I hope this is very clear. Adedayo, are you getting it? Omolayo, are you getting it? All right. Olufemi, how is it going? Good, Abi. Joseph, how is it going, Joseph?
I'm sorry.
All right. And John raised to power 2. John 1 and John 2. How is it going?
It's fine. It's fine. I'm enjoying it.
Okay, all right. Okay, fine. Then Esther, how is it going? Okay. All right. So let's move to unit 4. Let's go to unit 4. We are going to round up, not rounding up unit 4. We are going to round up with something there in unit 4. We are going to round up with something in unit 4. So not rounding up entirely with unit 4. Unit 4 actually is talking about components of a vector. Told you have to move with the speed of light. We need to cover, if you can try and, even if it's not, or if we can try and cover maths, physics, chemistry. You understand? Biology is very easy to read and understand on your own and just flow. Maybe CIT. We cover it, you go into the exam or you trash it and walk away. Do you get? So it's very, very important. So components of a vector. Adedayo, you want to say something?
Yes, I can see the board clearly.
Is that applicable to every other person?
Yes, yeah.
Oh, okay, let's hold on. I guess that should be network. Let's hold on a bit. That should be network. Can you see now?
Yes.
Okay. All right. I guess that was a light. Okay. We say vector AB. Vector AB is defined by its magnitude, arrow, and its angle, theta. So there's a diagram. There's a diagram that explains it, and the diagram is this way. So there's a vector AB, a vector showing its movement AB. They say vector AB is defined by its magnitude, arrow. The magnitude, the word magnitude. Can anybody remind me what magnitude means? What's magnitude? What is magnitude? Magnitude. I'll wait for that answer. Very important. What is magnitude?
Force or intensity.
Intensity also.
Intensity.
Okay. Yes. So the force that is exerted on A, taking it to a particular direction. So say vector AB is defined by its magnitude, arrow, and its angle, theta. So that means vector A has magnitude. Aside having magnitude, the movement of its magnitude actually results to having an angle. It results to having an angle. So that means the vector is moving somehow like this. It is not moving like this. So the way it's moving, so it's be AB. This is how the vector is moving. It has an angle. This is the angle. So one thing you must know, like I've always said, the English part of mathematics, there's a vector is moving at a particular, there's a force that's exerted on A to B, AB, moving in this direction. Vectors have magnitude and direction. Where is the direction? The direction is telling you now that the direction that is having, the particular vector AB is having, results into an angle. So what's the angle? So now that the vector is moving this way, as represented in this diagram form. So you have this movement, you have a movement like this. Vector is also moving this way, and is also moving like this from the diagram that is presented to you. So they said that from the diagram, it is defined by two components in the AY. There's Y here, and there's X here. There's Y here, there's X here. So you can join this. This actually is supposed to be a broken line, which is, this is B, this is arrow, this is A. So here like this is actually supposed to be a right angle triangle, the whole of this, if you have only this movement this way. So if I want to get the value of this part, it's actually supposed to be 90 minus theta, whatever it is, 90 minus theta, for me to get this value. So the value of this part is 90, because the whole of this like this is 90. Do we get that? So, but don't bother about that one. I'm just bringing up something. Don't bother about that. So it says AB is equivalent to a vector A in the AX direction plus A vector B in the AY direction. So what they are trying to say is that AB is equal to A plus B, A plus B, A plus B. The value of AB is equal to A plus B. If you add this part and this part, it should give you this part. That's what they are trying to prove. But there is somewhere it is all going. I don't want you to break your head about this one. There is something I need to show you on how to actually handle components of vector. So don't break your head about this one, because this you are not going to come across it in any way. So this is what you need to bother yourself about. You have something like this. If Z1 is equal to 3i plus 5j and Z2 is equal to 7i plus 3j. This is find Z1 plus Z2. Z1 plus Z2. So what you are going to do in this part to solve this particular equation, this is what you are told to do. Z1 plus Z2 is actually equal to what you are going to arrange now. You bring 3i plus 5j plus 7i plus 3j. You bring them together because this is Z1 and the other part, this is Z2. So what is the value of Z1 and Z2 so far? What you are going to do is you collect the like terms. So you bring 3i plus 7i plus 5j plus 3j. When you collect them together, you group it out. 3 plus 7, you take out the alphabet, plus j, 5 plus 8. So your answer is actually 10i, because the number should come first. 10i. 3 plus 7 is what?
3, not 8.
Where? Oh, sorry. Okay, 3. Thank you. You know, my blood is hot. So plus this is what? 8j.
8j.
I was already trying to go to the answer. That's why I wrote 8. So did you see that? You see, this one is very simple, very straight to the point. So now the next question is, what is Z1 minus Z2? If we have it like that, what is Z1? We have gotten the plus, the addition. So let us do the subtraction. So we have 3i plus 5j minus 7i plus 3j. So we still do the same thing. We collect like terms. So this is going to be 3i. This comes this way, it becomes minus 7i. This goes here, 5j plus 3j. So you bring it out. This is going to be 3 minus what? 7 plus j, 5 plus 8. So if you do 3 minus 7.
That is 3, not 8.
Where? This is 3 now. 7.
The same place.
Oh.
No, J.
God will help me. All right. Okay, so let us go. So what do we have here now? It's going to be a negative value. So you have minus 4i plus 8j. So there you must always consider the signs. You must always consider the signs in this particular aspect. Always consider the signs. Did you see that? So that's how you get that particular answer. So let's try one more or two more. If we have if B1 is equal to So we have 2 questions there. We have 2 questions. So let us look at it. So we just bring in the values for the first one. We bring in the values. We have for A now, B1 is 3I plus 5J plus 7K plus 6I minus 3J minus 5K, let's manage space, plus 9I plus 6J plus, sorry, I think we really need to manage the space. So let me write it small. 3I plus 5J plus 7K. That's for B1. B2 is plus 6I minus 3J minus 5K. B3 plus 9I plus 6J minus 3K. So we just collect like terms. Let's take, this is 1, 2, 3. So let's take them together. 3I plus 6I plus 9I. Also remember that alphabetical order arrangement matters. So you don't go and start from K. You have to start from is I, J, K. So for example, if it is not I and J that is given, it can be A, B, C. But usually it's always this I, J, K that is you always see. So then we take the next is J plus 5J plus, okay, where's the next one? 5J minus 3J. What goes next? And plus 6J. Then we go next K plus 7K minus 5K minus 3K. So let's group them together. We bring the I out here. 3 plus 6 plus 9. We put the plus. We group this one out. J. We have 5 minus 3 plus 6. We're going to put the plus down because we are adding. Remember, we are adding. So then you bring the K out. You have 7 minus 5 minus 3. So let's add them together. 6 plus 3. Let me come up. 3 plus 6 plus this. This is 9 plus 9.
18.
Is what? 18I. Plus, what do we have here?
8J.
8J. So
8J.
5 minus 2 plus this is what? 8. 8J. Plus, what do we have there?
Minus 1 minus K.
Minus K. 7 minus 5, 2. 2 minus 3 is what? Minus K. So the minus will what? Will affect this. So this is called minus K. So that's for A. Did you get that? So let's solve for, at this point, let us solve for B. So what we are actually going to have there is, this is where the signs will change, minus, and this is where the sign will change again, minus. So if we collect it together, we are going to have, let's just put it straight, I. So the first 3, what's the next I there? Minus 6. What's the next I there? Minus 9. Minus, remember it's minus that will come in. Then the next is J. The next 5 minus 3 plus 6 minus K. 7 minus 5 minus 3. So we go 3 minus 6 minus 9. Yes, help me.
Minus
me.
18.
Minus 18.
Minus 18.
Minus 18I. So we'll bring down the minus. So what do we have next? 5 minus 3 plus 2, 8.
8.
So 8j. So bring down the minus. What do we have here?
Minus k.
Minus k.
That plus k.
Yes. So it's actually minus k. It's minus, okay. Okay, 7 minus 2. Okay, all right, plus k. Awesome. Very good. So you see, they're almost the same thing. It's just the signs. Usually, sometimes they will even give you the options. They will give you those options and it will look alike. They can even give you for this A part. They put this among the option for you. They put this and they put this. You now go and get confused if you did not follow the signs very well. All right, so that is where we are going to stop for today. I hope you all enjoyed the class. That's where we're going to stop today.
Yes, sir, we did. Thank you.
All right, very well. So we're expecting A's this time around. A's all through in this semester by God's grace. All right, have a pleasant.
No, amen. No.
All right, so have a pleasant night rest, everybody. Thank you so much for your time. Good night.
Thanks, sir.
All right, bye.
Good night, sir.
Good night.